this is my favorite thing that we get to do in all of Precalculus. And if you don't like it, that's okay. What's my favorite does not have to be your favorite, but I think this is so cool. So what I have done today is I have picked some graphs that are just plain cool. They are polar graphs, and some of them might use some pieces that we are used to seeing, and some of them are just crazy, and people played around with them and figured out how to make some really cool things. So some of them on here are Desmos graphs, and the second page actually work better on the TI calculator to see than they do on Desmos. So let's go ahead and first look at some of the exciting Desmos ones. I wish we could do this together because it's kind of weird to be just excited by yourself, but hopefully you can do this on your own and share the excitement with me. And maybe I would encourage you to type in at the same time, have the same reaction as me so you can play around with some values and see what happens. So here's what we got. First graph is a little crazy. Here's how we're going to do this one. So it's r equals sine, and you can leave that squared off for right now. So sine of 2.4 theta, and then you can just make sure the square doesn't go inside, but you can square the outside, and that works. First, before we even add in the next part, this one's pretty cool. That's what that looks like, and I really like it. So, okay, that's our first one. Plus cosine of 2.4 theta, which before you even raise this to the fourth power, I mean, like, these graphs are incredible. Just admire them partway through the process. We have this like flower with the cool wave around the edge of it, and now let's go ahead and finish it off to see what happens when we add the fourth power, raised to the fourth power. Whew! And here we have it. I think this is so insane. This is a like circular wave version of things, and let's see what happens real quick. If I take the grid and the axes off, I get this. So that is very cool. And when I remember getting to Precalculus and never thought I would be able to even remotely understand or type in a graph that looks something like this. So here we have it. All right, that's the first one. Let's go ahead and make some modifications on this because the structure remains relatively the same. We put the grid back and the axes. Okay. What I'm going to do is I'm going to change 2.4 to 1.2. Oh my goodness, look at this. It's so fun. This is so crazy. Okay, 1.2. Woo! Even this, it gets better, but even this is so cool. Look at that. Look at that. Oh my goodness. Okay, next up, let's change this to a 6. This is what I like about Desmos is it can change. Oh my goodness. Like, look at this. Okay, all right, this is cool. This is even cooler, and we are not done. Let's raise this to the third power. Oops. Whew. All right, here we go. This is our next polar graph. Again, let's take the grid off and admire what we just did. Oh my goodness, look at that. Look at that. That is one function. That is one polar function. Can make all of that happen. That is incredible. Okay. All right, next up. If you have marveled in it long enough and are ready to move on, we're going to keep going to the third one, which is r equals sine of theta plus cosine cubed of 5 theta over 2. Let's go ahead and add back in our grids. Okay, I'm going to get rid of the square. Oh my gosh, it's so good. Woo, look at this one. Interesting. Okay, all right, so we have cosine cubed. That's kind of fun. Okay, of 5 theta divided by 2. Oh my goodness. Look at this. It looks like a seashell or something from The Little Mermaid. Ah, it's so cool. Okay, I'm just going to admire it again. Ah, look at this. This is a polar graph. There are no x's, there are no y's. The only reason this works is because we can graph in the polar form. All right, this one is very cool. Okay, the last one is going to be really annoying to type in, but I hope and promise you that you will find it to be worth it. Okay, here we go. I'm just going to change the color. I'm tired of the green graphs. I'm going to change it to red. Okay, here we go. kind of long. R equals 3.5 minus 1.5. That's absolute value. So absolute value of cosine theta. So what's happening? Ooh, that's kind of fun. Okay. Oh, no, I just accidentally deleted it. Okay, there we go. Times the square root of 1.3 plus, what comes next? Absolute value of, sorry, I lost this. Absolute value of sine theta. Okay, might be thinking, where's this going? Okay, and then plus cosine of 2 theta. All right, it's getting better. Close those parentheses. Minus 3 sine theta. And then plus 0.7 cosine of 12.2 theta. Okay, are you ready for this? Look at that! Oh my goodness, look at that. That is so cool. We just made an incredible heart shape figure graph out of a polar graph. We made a special cardioid. It's got all those curves. Look at that. That is so cool. So if you want to play around with it, I would encourage you to. So these are the main Desmos graphs that I have for you here. And so then next up, what we're going to do is we're going to look at a couple cool graphing calculator graphs. And in order to do that, I am going to use the graphing calculator app on the computer. And then we are going to look at some of those graphs from there. The spirit of honesty, sometimes you record a video for a clip and it's perfect, works great, and then you don't know, you save it and then it disappears. This has happened to me before. It did it again. So here we go. This is our second try for this one, but I promise you this is worth it. These are some incredible graphs. First thing we need to do is set up our graphing calculator. So first thing, if I were to try to graph a polar coordinate right now, in y equals, this is not going to work and it's not going to do what we want to do. So we need to click mode. First thing we want radian mode. This is so important. If degree is currently highlighted, if it is darkened, then we don't want that. We want radian highlighted. Next up, you should currently in the line below it or right nearby, if you have a couple of extra options, it should say function. If you look next to it, it says parametric and polar. We want polar mode, so we're going to click enter. Now here's what happens. Once we do this, go back to y equals. Oh my goodness, look at that. Interesting. Now instead of saying y equals, it says r equals. So what we're going to do is we are going to type in the function for r equals. Now one other thing I want to show you is that the window options have changed, and this is going to be really important for us. There's still x minimum and x max, which tells us what's the left and right numbers we want it to go out to, and then the bottom and top numbers, y min and y max, but it also gives us theta min and theta max. This tells us how much of the curve, how far out to go, which we saw in the notes. And that's all going to be given in this chart here. So the first thing we want to graph is r equals 4 cosine of 64 theta. And this is really cool. Actually, let me go back there. When you go to find theta, you're going to go looking all over. The variable button that we usually press for x, if I click that right now, it types a theta. So it's the polar mode turns x to theta, and so that's what we need to use. So 4 cosine of 64 theta. Next up, let's click window. Now here on the notes, it's going to tell us what to do. Theta minimum, 0. Theta max, 39. So we're going to go and whatever you have there, I don't know what it gave you, but we're going to type 39. And then theta step is how much our table is going up by the angle we're plugging in. So it's going to approximate those numbers and then plot those. We want this one to be 0.1. And then we want to change this. I already have it, so I'm not going to retype it, but x min should be -6. X max should be 6. The x scale, that's the tick marks they put on the axis. We're actually going to put 0. It will get rid of our axes for us. And then -4 to 4, y scale 0. All right, you guys ready? This one's awesome. Here we go. 3, 2, 1. Oh my goodness. Oh my goodness, look at that. That is so cool. Oh, I love it. All right. That's awesome. Okay, take this one in if you need another moment. Awesome. We're going to modify it. Number 2 is the same graph, except we're going to change it from 0 to 2 pi, and we're going to change the step to pi over 24. So it's going to be a little more precise with what it's evaluating for angles. Okay, so we're going to go 0 to 2 pi, type in the pi value, and then theta step, we're going to go to pi over 24. Same x min, x max. All right, 3, 2, 1, ready? Oh my goodness, look at that. Look at that. That is so cool. I honestly, like, I can't even fathom how that works. Math is amazing. Oh my gosh, that's so cool. Okay, awesome. All right, so that's our graph. Cool. Okay, so now that we have done this, and now that we have looked at our function, we're going to look at a couple more ones as we go from here. Now, here the next one, just so you know, I'm actually going to go ahead and pause and type all these in because it is a lot to type in. So if you look at this, I'm going to type in all of these functions into R1, R2, R3, R4, R5, R6, and then the video will pick back up when we go from there. So your next task is to type all those. This one, so I have now typed in all 6 of these. So it does take a little bit of time, but I promise you, oh my goodness, it's so worth it. It's so cool. Okay, the window is actually what we had in before. So we don't need to change anything about the window if you had typed in the same window as the second one. So that 0.13 number we're seeing is pi over 24. Okay, let's go ahead and click graph. Oh my goodness, that is so cool. Look at that. I love that. It's like a logo with a line around it. That is amazing. That is so cool. Okay. All right. That one's awesome. We're going to look at, I'm going to show you 2 more that I really like in here. And then from there, if you want to explore the other ones, there are just some, again, incredible things that happen. But I'm not going to go through all of them just because I know that you guys can do that as well on your own. So this next one, I'm actually just going to go ahead and keep the video running and modify it because I can do it pretty quickly. So I'm sort of typing over the structure that we already had there because the change is not that drastic. So I'm just changing what I need to so that we get all these 4 cosines. So then R4 is 4 sine. And actually the order you type these doesn't make a huge difference as long as you have all of them there. So you don't, if you didn't necessarily want to go, actually it looks like I'm a little bit out of order here because I typed and I'm just feeling like I don't want to cover that. So okay, 4 sine of 2 theta. It looks like we have everything. Okay, the window is what we've been using, 0 to 2 pi, pi over 24. Okay, so if you need to pause it, type this in. Okay, this one's awesome. Here we go. 3, 2, 1. Oh my goodness, look at that. Like, there's the layers, the way it turns out. Oh my gosh, that is beautiful. Oh my goodness. Like, here's the thing. I would love for you guys to pause and take a moment here. You might think I am crazy, but these graphs are incredible. And this is actually, when I saw these in pre-calculus, this is when I first started to understand, like, math is one of the most beautiful things out there. The reason that numbers and connections and our theta coordinate points can form something like this and can actually model and what we've seen in the real world and create beautiful designs. That's incredible. Okay, I've got one more for you. Actually, you know what? I would like to end on this one. The next ones I have are really cool, but this one is just, I think, a very beautiful design. So the ones on the next page, I'll click over to this. There are some really cool ones, and they're actually not as involved with typing in. So if you want to look at them, honestly, I included all of them because they're all so cool to see what happens. Number 9 is especially neat because as you change the step, you'll see different things happen with it. That's really cool. Make sure you set the window to be right. So if you're looking for some joy, something beautiful, something mind-blowing, graph some of these and enjoy these really cool graphs, then let me know which ones you enjoyed. I would love to share that with you from there. So look at these graphs, and then if you want to practice graphing some of your own with the 9.2 practice, go ahead. That is an awesome thing. And then look for some finals review materials coming from here. This is my last section that we have this year in pre-calculus. It has been an honor being your pre-calculus teacher. I'm excited to finish the year strong. This is one of my last virtual lessons even too as Miss Tilley, which has been incredible as well. And it'll be exciting new journey with my new married name. So if you've stuck this far in this video, congratulations, and we'll go from here. All right.